So yeah, Argan diagram is the geometric representation of complex numbers. So now we will understand how this Argan diagram looks like. So the Argan diagram has xy axis, right? But the x-axis is considered to be real of z. Okay, so that we call real axis. The y-axis we call imaginary axis. So imaginary of z. Okay. So now, for example, if you have z is equal to 1 plus 1i, then this is the real part, this is the complex part or imaginary part. Now what is the coordinate here, right? So you can think that on the real axis you have x coordinates, on the y axis, on the imaginary axis you have y coordinates. They originally represent the imaginary values and real values, but you can sort of place the coordinates. Now the x value here is 1, y value here is 1, right? But what is the imaginary value? So imaginary value would be like I times 1, right? So now if you place the coordinate 1 and 1 here, so this is the place that we have the final coordinate, the complex number. So how do you draw that? You are going to draw it like this. This is z. Okay, so now if you see, the horizontal value here, that would be 1, but if you look at the vertical value, that would be 1 times I. Now 1 plus 1 times I, you get z. The next one, we will get few examples here. First one is I. Okay, and then I need to draw I squared, right? I to the power 3, right? And I to the power 4, and we'll see how to draw all of these, right? So now they are complex numbers, so you have real of z, right? So all of these are z values, right? So this is imaginary of z. Now I should be on the imaginary plane over here, right? Over here the coordinate would be 1 because this is 1i. Okay, so that would be 1i. z1 is equal to 1i, so that would be here. That is z1. Then what about z2? z2 is equal to I squared. What is I squared? I squared is equal to minus 1, right? So that tells you, okay, from here minus 1 is here. So this is your z2. Then what about z3? z3, that would be I3. So that is I times I squared, so it's minus I. So minus I should be on the imaginary axis, so it should be here now. So it goes down. So this is minus 1, but on the imaginary axis. So now z4, that is I to the power 4, so that is I squared times I squared, so it's going to be 1, so it's going to be here. So now this is going to be z4. Now what we can summarize here is this: you take z1 multiplied with I, then you get z2. You get z2 multiplied with I, you get z3. Then you get z3 multiplied with I, you get z4. So what is happening here? So the complex number is having a anti-clockwise rotation. like this way. You can see z1 to z2, right? When you multiply that by I, you get z2. But importantly, when you multiply by I, the rotation is with angle 90 always. Now we will sort of elaborate that example. Suppose you have z, which is 1 plus I. Okay, so now I'm going to draw that. So this is our real plane and this is our imaginary plane. 1 and 1 would be somewhere here. Okay, say it's here. This is your z, right? So if I do z1, which is I times z, now without going into details, we know that I times z means the rotation of z in anti-clockwise direction by 90 degree. So that would be somewhere here. Okay, but what we know is this angle would be 90. This is your z1. Now if you go into details, you can find the coordinates. So now we will go into details. So z1 is equal to iz, so that would be I times 1 plus I, so that would be I minus 1, right? So if you write minus 1 plus I, so that would tell you this one would be minus 1, this one would be 1 here on the imaginary axis. So addition of complex numbers, geometric representation. Let z1 and z2 be complex numbers. So then let's draw that in our Argan diagram. This is real axis, imaginary. So let z would be here, z1, then z2 would be here. Okay, so what is the addition? Z1 plus z2. Okay, so what is the addition? So you know how to do this analytically, but pictorially this is very much similar to vector addition. You have the parallel lines here and this is going to be z2, right? So z1, z2, so this one would be your addition, which is z. So z1 plus z2 is equal to z. So now we'll discuss one example here, the geometric addition of two complex numbers. So let z1 be 1 minus 4i and z2 be minus 2 plus 2i. Then we have to find z1 plus z2 and show that geometrically. Okay, so this is what we need to find and show that geometrically. So now first of all we will find z1 z2 analytically. c1 plus z2 would be 1 minus 4i minus 2 plus 2i. This is equal to minus 1 minus 2i. Now we know our resultant, right, z, right? So addition of those two complex numbers. So now pictorially we have to draw that. So this is real part, this is imaginary part. First of all, z1 is 1 minus 4i, so 4i is here, 1 minus 4i, so it should be here, right? So this is going to be your z1. So this is z1. So this coordinate is 1, this coordinate is minus 4 on the imaginary axis. So now what is z2? z2 is minus 2, 2i. Okay, 2i means over here, minus 2 is over here, so it's 2, 2. So it's going here, right? So this is going to be now your z2. Now as you know, the resultant, now where is the resultant? So the resultant should be somewhere here, okay, somewhere here. Now we will check where is the resultant is at. So resultant is at -1, okay, here, and -2y, it's here, it's here. So the resultant is here. So that vector z, this will, not vector, I mean you can say it vector, but it's in the complex plane. You can say this is z, complex number is nothing but the resultant of z1 plus z2, or you can say addition of z1 plus z2.